Good morning. Thank you for joining us today. I am Manat Viyapornpan. I will be your moderator for this presentation. This presentation is in topic of benefit of Mitsubishi high pressure shell compressor. The presenter of this presentation is Mr. Win Lung Hiransukun. His service years at SCI is around 7 years. So he's taking care for USA market and also Canada market. So he will come to share his experience of Mitsubishi high pressure shell compressor with you in a few minutes. So please wait for a moment. Thank you.
Good morning, everyone. My name is Win Lung here as Sales Engineer for North America region. I'm working at Mitsubishi Compressor Factory in Thailand. And thank you, Mr. Mana, for helping introducing me. So today I would like to share you about the benefit of Mitsubishi high pressure shell compressor that might be useful for your testing in the future. So let's start with this slide. Mitsubishi, we have supplied our compressor to many countries around the world, not only in Asia, but also in Europe and USA or Canada. There is a lot of interesting in inverter technology because now inverter technology is trending worldwide. We have supplied our product not only in cooling application, but also in heating application and industrial application also. So I would like to say that Mitsubishi, we have a lot of experiences in various type of product that could support you. I believe main goal for the unit maker is to get the best efficiency and the best reliability for the customer. And in order to get better efficiency, I believe inverter technology is your answer nowadays because we all know well that inverter technology has a lot of benefit that like you could get better efficiency at high load condition and also less power consumption compared with the fixed speed solution. And in terms of better reliability, I would like to give you that benefit that you could get from using our high pressure shell compressor, that you could get better reliability for your system also. Start with the question is what is a high pressure shell compressor, because some of you might have this question and don't know how does it work. So I would like to give you a short explanation about how high pressure shell compressor works. You could see in this presentation that the blue arrow is the suction port. So the refrigerant flow will come from the suction and go into the compression chamber to compress the refrigerant and then discharge out at the top of the compressor. After that, the refrigerant flow will go down to cool down the internal part and motor of compressor before discharge out at the discharge point, as shown you in the red circle here. So with this design, uh, the pressure inside our compressor is very high. Also, the temperature is high also. And there are two main benefits that you could get from this design, like a high pressure shell compressor. The first one is you could reduce the oil problem at hard load condition because our product, we use the pressure differential in order to supply uh, oil for the internal part. And the second benefit is we could allow some liquid refrigerant that could go into the suction side by using a discharge, so we heat control. So I will explain you in the next slide about the detail of these two benefits. Start with the first benefit, the oil supply by using pressure differential. So the concept is because at the top of the compressor and at the bottom of the compressor, there is a pressure difference. So we use this method in order to supply the oil from the bottom to the top of the compressor. Like this orange arrow in the presentation, it shows you the oil part from the bottom to the top of the compressor. And if you still not, worry about this concept, we also did many confirmation tests like at the severe condition, for example, high load condition, high compression ratio condition, or high temperature condition, not only inside the operating envelope, but we also test outside the envelope also to ensure that with our product, there will be no problem about the oil supply using the differential pressure concept. And this slide show you like an example, and how easy in order to use our compressor. So thanks for the benefit from pressure differential. So our compressor doesn't have the oil pump inside the compressor. So we don't need to boost up the speed. So which means you could play with the speed. Like for example, this is the example of one of our scope compressor. There are two main areas, area 1 and area 2. For the area number 2, which is the main area, you could play with the speed like 15 to 120, which is the maximum speed without any restriction, just only to control the discharge temperature, not higher than our limitation. For this model, the max discharge temperature limitation is 248 degrees Fahrenheit. So just only to control this number, that's all. So it's very easy to use and easy to control our inverter scope compressor. And the second benefit is our compressor to allow some liquid refrigerant at suction by discharge, so the heat control. And you can see that in the yellow arrow, that is the example of liquid refrigerant that might come into our suction side. And because of our compressor is high pressure shell, so the temperature inside is very high. When the liquid refrigerant comes into the suction side, it will be evaporate very quickly. Besides, our internal part, like a combustion chamber, it had a special coating that could manage the liquid refrigerant also. So that is the benefit that you could receive by using our compressor. And with this concept that we could use the benefit from liquid refrigerant like oil return by oil washing method. So the main concept is we adjust the discharge superheat in order to get the liquid refrigerant in order to bring the oil back in the liquid state. And by using this method, there is no need to boost up the speed in order to retain the oil that there is no effect to the capacity of the unit and the efficiency of the unit also, because we don't have to change the speed. That is the main benefit that you could get from the design of the high pressure shell compressor. And only available with Mitsubishi Go compressor, we have a flame compliant mechanism, which is the Mitsubishi patented technology. From the actual test result, we could increase the performance about 14% compared with the conventional design. This technology is we optimize the pressure chamber inside the compliance frame in order to minimize the two losses. The first one is the leakage from compression, and the second one is the thrust bearing loss from the design. That's why we could increase our performance a lot, about 14%. And we have put this technology in all of our scope compressor also. We also did the conformation test like a liquid starting testing. This diagram in this presentation show you how we perform the test. So we have a liquid refrigerant tank connect with the solenoid valve and connect at the suction side of the compressor. And we open the valve and allow the liquid go at the suction side, and we do the test with our compressor. Other we have a tear down analysis to check the internal part. You could see from the picture below that in conclusion, there is no abnormal bearing part after the light test confirmation. So we could ensure that this concept works well with the high pressure shell compressor. And not only the two main benefits that you could get from using the high pressure shell compressor, we have a lot of technology that we put in our scope. So this slide show you in summary what is we put in our scope. The first one is asymmetric scope design that we design in order to reduce the loss from compression leak and increase the stability of the refrigerant flow in order to increase efficiency of the unit in the system. The second point is the low oil circulation. So we have an oil partition technology that we put inside our compressor. We also enlarge the oil tank so we could reduce the oil circulation ratio, about 50% at startup and about 10% at steady state compared with conventional models. Third one is the new suction structure you could see from this compressor. So we put the suction side at the top of the compressor so that we could increase the performance at high speed operation by a larger suction volume. The next is a relief valve technology that we optimize the compressor performance at and efficiency when operate at compression area. We also have a high efficiency motor, so this is specially designed for our stroke, and we're also using a rare earth magnet, which is a high grade magnet in order to make sure that our reliability of our motor is very high. Next is we have wide running range, as I showed you in the before about our operating envelope. So customer could use from minimum 15 RPS up to 120 RPS without any restrictions. So very easy to use our scope. And the last point is our scope is much quieter compared with our competitor. So from the actual test result of the sound level, our scope have sound level lower than our competitor, about 5 to 7 decibel, because we have a discharge muffler that put inside our scope. And Mitsubishi, we never stop. So this is show you our future plan. Like in the near future, we will have 3 new models that will increase the capacity of our lineup. So we have the 3 sizes, First one is the ANB 100cc, BNK 110cc, and the last one is BNK 128cc. So with the larger size, 128cc, you could go up to 23 tons in terms of the capacity. We also have put many new technology in our new product, like a wafer injection, new internal structure, or very low speed operation, like a 10 RPS that customer could go lower than our conventional model. Also, it will have high performance and low oil circulation also. And this slide show you our total lineup, include our product in the future. So the smallest size we have right now is 5 ton. This is the DNB 22cc, and the biggest size at this moment is ANB 87cc, which can go up to 15 tons. But in the future, as I said, with BNK 128cc, it could go up to 23 tons. And if you want to use our compressor in tandem, I would like to say that we have an option to do a tandem configuration as well. So for example, with 128cc, you could connect like a 4 unit in one circuit. So you could reach like a 94 ton in terms of the capacity when our BNK 128 is available. And for customers who use our product in low ambient temperature, we also have the wafer injection lineup available for your unit or your system. And one key technology is we call the injection valve. So this valve will close when there is no use of the wafer injection feature. So which means that you could use our wafer injection at low ambient temperature and at the regular ambient temperature also. And this is the last slide that about our future that Mitsubishi will go. So this is show you the plan about alternative refrigerant that we are now working with. For example, for high pressure refrigerant, right now we have our 10A that are already in mass production. And we also have R32 that already in mass production also, and we already supply to some of our customers in Europe. In the future, we have a R454B lineup available next year, and for medium pressure refrigerant, we have R448A for refrigeration application. And the last one is low pressure refrigerant like a propane or R290. It is now in mass production and already supplied to the market. And this year we plan to launch R513A for chiller and air dryer application also. And back to my first slide with for better efficiency, we know that inverter technology might be an answer, and for better reliability, I would like you to try to use our high pressure shell compressor. That is a lot of benefit that we could provide, as I explained to you during my presentation. So if you want any further information, please feel free to contact Mitsubishi. We have a lot of product that might be able to answer your requirement. And now we go to the last session for today is Q&A. I could saw that there is a lot of question from the question box. And sorry that we might not be able to answer all your questions due to the time, but feel free to leave your email, and my team and I will answer your question by email as soon as possible after this live event is finished. So Mr. Mana will help me to pick up some questions that might be interesting today.
Yes, please allow me to pick up 4 questions to ask Mr. Win in this presentation. So the first question, Does Mitsubishi have low pressure shell compressors?
Okay, so about this question, right now, all of our product is high pressure shell compressor, so we don't have a low pressure shell compressor at this moment. But as I explained to you, there is a lot of benefit that you could use the high pressure shell compressor.
Okay, so let's go to the next question for the second one. How can Mitsubishi support for testing in USA?
This is a very good question. So for USA or Canada, we have a special team we call customer application support team that we set in order to support the customer testing. We have an engineering team that could answer all of your questions that you may have about using our compressor, and we also have our testing facility that customer could send their unit to us in order to fine tune like a matching with their unit with our compressor. We also have our technical website that customer could log in to get all of the technical information. Also, performance calculation is available as well. And the last important thing is that we also have like the piping simulation team, because for example, like an inverter compressor piping is the important thing that customer have to make sure as well that the piping design is safe enough in order to prevent the pipe crack problem in the field. So customer could send us that 3D piping design to our team, and we will make a 3D simulation and send back you the analysis report. Or you could download our piping general recommendation in the website as well as they is available in the 3D. Also, you could just download it and put it in your design. That is very easy.
Yes, also, thank you very much. I think this answer is very complete and really understandable. So for the third question, is there any other component to prevent oil loss?
Okay, we have oil supply by using pressure differential, but if you would like to add more component, you also have an oil separator in our product list also. There is a spec and detail in our website, or leave us your email. I could send the specification and information about our oil separator to you later.
Okay, now we are coming to the last questions for today. So the question is, how can we make sure that oil in the system is enough?
In terms of oil, we usually we will recommend our customer test the sample with the cyclone also in order to make sure that there is enough oil in the system and the high load condition. So we could prepare and provide you with the sample with cyclone in order to confirm about this issue. I think that is the last question, and I would like to thank you for joining me today for the presentation. And for more information, please feel free to visit our website www.siamcompressor.com. There's a lot of information about our product, and our component like a oil separator is available in the website also. And if you have any question, as I said, so feel free to leave your email here, and we will contact that as soon as possible. Finally, thank you. Thank you for your attention, and hope you stay safe, and looking forward to seeing you soon. Thank you.